So thank you so much, everyone, for joining today. My name is Nick. I help with solution architecture and technical enablement at Kaleido. And today we are going to be taking a look at something fresh off the presses, sort of the V1 representation of Hyperledger FireFly on Kaleido, including the interactive sandbox. So we'll take a look at all of the core functionality, the API surface, and try to get you guys a better idea of how easy it is to, sort of really accelerate your Web3 applications. Not a ton of slides today. We'll focus mainly actually on the user interface and on the product. Just quick agenda. We'll do a brief overview of FireFly. I'll take you through the console, and we'll go through the various steps to actually create a consortium and create a FireFly environment on Kaleido. We'll look at some one-off things that we're going to do with custom smart contracts and ERC20 tokens. And then we'll spend the majority of this demo actually using the sandbox, right? And so everything I'm going to do is absolutely available to anyone on this call, anyone that has just created a free or a paid Kaleido account. There's no barriers here. So if you want, feel free to even follow along in real time as we're doing this. I'm going to do it with organically created assets, so we won't have pre-baked environments. So you should be able to kind of move along at the same speed that I'm going. So just a couple things of sort of why FireFly exists out in the world, right? I'm sure a lot of folks that, regardless of where you are on your blockchain journey with an enterprise, with a startup, with a fintech, whomever, you've realized that, building these full stack enterprise grade blockchain applications is really a non-trivial exercise, right? There's tons and tons of different pieces and different problems to solve, right? And this slide does a good job of, kind of identifying some of those, really, really important and really tricky things, right? Decentralized architecture, just the core protocols that we're dealing with, whether it's Ethereum or Hyperledger Fabric or R3 Corda, the importance of digital assets, right, and tokens inside of your ecosystem, whether you want to pay for data or whether you just want to use them, as representation of fungible, all things around key management, right? Do we manage our keys off chain? Do we manage them in a utility? Do we integrate maybe with, some sort of cloud service like an HSM? Privacy. We'll spend, if you've joined a previous webinar, we talk a lot about privacy, and privacy is so critical regardless of what industry or what vertical you're in, right? And so you have these, different levels, different classes of data of what can go on the chain, what can go off the blockchain, and how do we move that data, in an encrypted format throughout this ecosystem. Events are incredibly important, right? How does your application, how does your business process get notified of real-time state changes that are happening in the system? On and on and on and on, right? I'm not going to read every single one of these bullet points, but you get the idea that, there's a whole slew of things that you need to address and you need to get right. And that's FireFly, right? FireFly is a SuperNode. It is a Web3 orchestration layer. It is a blockchain gateway and has this wonderful, expansive API surface that handles all of those things that we just talked about, right? Easy interfaces to speak to your blockchain, reliable events coming out of the system, message buses for public and private data, key management, so on and so forth, right? And so it's this high-level orchestration layer that sits above your blockchain. It becomes your, orchestration layer. It becomes your Web3 gateway, and it truly is your SuperNode. And so you can, use as much or as little of FireFly as you want. It's inherently pluggable. It's meant to integrate with your existing cloud estate, with your existing back office systems. And you have this really flexible approach, right? You can go directly to your blockchain node. You can talk to the blockchain through the FireFly APIs, right? You can handle privacy and public data in all of these different manners right here. But all of this functionality is encapsulated in a single common REST API surface so that, as an application developer, you can focus your attention on, the three core things that matter, right? Integrating with your existing systems, right? Creating really robust and really sophisticated and rich business logic, i.e. smart contracts, and then putting a beautiful interface on top of it, right? You don't have to worry about all of the plumbing, all of the esoteric things, all of just the tricky things that exist in blockchain and exist in overall full stack architecture. So that's kind of the table setting for where Firefly came from. We'll come back to a few of these sides in a more architectural sense as we're standing up the resources on Kaleido. So few pieces of housekeeping real quickly. Let me stop sharing this, sorry. So this is recorded and we post all of the recordings up to our Kaleido YouTube channel. So if you do need to drop early or you have a colleague or someone that might enjoy seeing this, this will be up in the next 24 or 48 hours. If there are any questions, we like these to be as interactive as possible. So just raise your hand, throw a question into the chat. I imagine there's some Kaleido engineers and Firefly maintainers that are on this call as well. So should have good coverage for any questions if you feel like asking anything. So with that, let's go ahead and create a consortia and a Firefly environment. So I'll start by creating a blockchain network on Kaleido. And again, it's free to create a Kaleido account, takes upwards of 30 seconds max, right? And once you've done that, you can use our free starter tier or paid subscription tier. And you can do all the things that I'm going to show you right now, okay? So we'll just say Tech Tuesday 510 consortium right here, okay? So I'm going to click next. Kaleido provides you fully managed cloud infrastructure, right? And so we support out of the box, AWS and Microsoft Azure with all of these regions. So you just get built-in, fully baked HADR, enterprise-grade backend infrastructure. So this is, one of the really, really attractive things about, Kaleido and Firefly is, not only do you have all of this really rich, really core functionality in Firefly, but you run that on Kaleido, and now you get all of this enterprise-grade, cloud infrastructure and blockchain expertise as well. So I'm going to run my resources in AWS in Ohio, but we see that there's tons of other choices that I have. And it's worth noting that you're not limited to a single cloud or a single region on Kaleido. You actually have very, very flexible options in terms of hosting topology. So we could have turned this into a cross cloud or a cross region network, and all of that low level layer 2 networking, all of that's handled by Kaleido. So if you have a diverse consortia and one entity wants to run on AWS in the States and another entity wants to run on Azure in Paris, for example, that's fully compatible and fully possible on Kaleido. So you have that rich flexibility available for you out of the box. Okay, so here's my namespace, here's my business network, my consortium, and my org is org ABC, so I get the first membership inside of this. And what I'm going to demonstrate is a facsimile of a 3-organization network. So I'm just going to go ahead and create 2 additional memberships, and this will be important when we start talking about privacy, right? Because if we only have 2 memberships, 2 organizations, nothing's truly private, right? It's just a bilateral transaction. But if we have 3 memberships, now we can very easily show, for example, org ABC and org GHI, for example, can share some blockchain data, they can share some sensitive off-chain data, and we'll go through the techniques and sort of the mechanisms to obfuscate and hide that data from this organization here. Very, very straightforward, very simple to do on Firefly. Okay, so that's the top level resource, the network or the consortium. I have 3 memberships in it. So let's move down a level and create what we call an environment on Kaleido. And so an environment on Kaleido is a completely firewalled namespace. So think of any environment as just your own private sovereign blockchain until you choose to decentralize your network and bring other entities on. And you can create as many environments as you want under your network, right? And so for folks that have their DevOps hats on, you can have a development environment, you can have a UAT environment, a staging, a production, so on and so forth. So with Firefly today, it supports Ethereum and Hyperledger Fabric, both with wonderful, wonderful pieces of smart middleware, respectively called ETH Connect and Fab Connect. We've looked at these quite ad nauseum in the past, but at a high level, what they are just abstractions of that underlying API. So you can just speak Web2, you can speak REST to your Solidity code or your chain code. We'll go through the Ethereum door today, just because kind of digital assets and tokens are bit of a more fully baked native construct inside of Ethereum. So I will create an environment called ffdev right here. And I'll go with fully managed in the cloud. But Kaleido does also support, I mentioned hybrid and flexible topology. That wasn't hyperbole. It's truly as flexible as you need it to be, including off of Kaleido, right? Running a node in GCP, for example, or on your on-premise mainframe. So if this is a business requirement, this is not a trivial sort of undertaking by any stretch here, but if this is a business requirement, a data residency requirement, a key location requirement for your consortia, reach out to us and we can talk about this in more detail here. Okay, so last thing I need to do is just choose my flavor of Ethereum. I'll go with Geth and proof of authority here just for simplicity's sake. We see that Quorum Raft is going to be coming soon, but Quorum IBFT is available today, as is Besu, and their different flavors. So Geth and POA it is, click finish, and boom, here's my namespace for my environment. It's empty now, right, because we don't have any nodes in it, but we can go ahead and bring it to life by creating some FireFly nodes and, okay, this is an important piece here, and their corresponding infrastructure, right? And so I mentioned back at the beginning when we were looking at those slides that FireFly sits above your blockchain, right? This term orchestration layer is a really applicable term here, right? It's there to orchestrate all things Web3, all things for your organization, for your business process management, right? Dealing with off-chain data, dealing with public broadcasts, right? And so in addition to your FireFly node, right, your operating system, your SuperNode brain, you also need a core blockchain node. And then you need a storage utility. You need a public storage utility. And for that, we use IPFS. So what I'm going to do here is I'm going to create a FireFly stack. I'm going to create a node in those corresponding blockchain nodes and IPFS nodes for each of these memberships right here, so that we kind of bake out, what would be, like I said, a facsimile of a decentralized 3-organization network. So we'll call this first guy FF node 1 right here. Going to click next. And now we see I'm prompted for those other 2 runtimes, right? I need an actual blockchain node. I need that Geth runtime using proof of authority. And then I need an IPFS node to store all of the public data that we broadcast and push through the system. Okay, so just going to click finish here. And these will take, I don't know, probably 90 seconds, right, in the aggregate to fully come up. So let's go ahead and just create the other 2 stacks that we need. So one for DEF right here, call this FF node 2, just go with the same naming convention, node 2 and IPFS 2 right here. Click next, click finish, and we'll do that one more time. I should note, if you're on the free starter tier, you're going to just be limited to 2 stacks right here. You won't be able to do like the cool thing that I'm going to show you where I open up a FireFly Explorer and I prove that an organization can't actually see this data, but you can still use the same constructs, right? The same privacy layers. So regardless of the fact that you can only use 2 nodes, you can really familiarize yourself with the core functionality and all of the really important flows through the system. So don't let that be a blocker if you can't completely copy exactly what I'm doing here, okay? And so for our last stack, again, just same naming convention, node 3, IPFS 3. So that means each of our 3 memberships right there now have a FireFly node, right? They have a SuperNode brain, a FireFly operating system. They have a corresponding blockchain node, right, using Geth and proof of authority. And they also have an IPFS node as well, okay? So while those are coming up, let's go ahead and go back to the slides here. Okay, so pressing forward. So we looked at these. Let's take a broader look kind of at the whole stack here, right? And when I say this is a rich, expansive API layer, right? That's truly what it is, right? It's giving you, all of this functionality, all of these touch points into so many things that are happening on the blockchain, off of the blockchain, stuff that's public, stuff that's private, stuff that has to do with bespoke business logic, stuff that has to do, with digital assets right here, right? And so we can kind of see the different buckets that exist, right, inside of FireFly, right? Great answers around security, right? Nothing in Kaleido, right, is an open API, right? Everything has boundary security. So whether you're talking directly to the smart contract, you're talking through the FireFly APIs, you're talking directly to your blockchain node, right? All of those ingresses are going to have boundary security. So that's very important. For stuff that's moving off of the blockchain, right? For example, in my scenario, if org ABC wants to send something to org GHI, right, we're going to have great levels of symmetric and asymmetric encryption inside of there. Network identity, this is incredibly important, right? I need to know unequivocally who is who inside of my network, what are their addresses, what are their runtimes, right? I need to be able to identify them with clarity and with sort of like this authoritative identity right here. And so we'll see these different organizational maps and see these address books and all these different utilities that help make it really, really easy to identify the counterparts inside of your network and see what assets they have as well. We've talked a lot about sort of like the REST API gateway and these easy interfaces, but this should not be overly trivialized, right? This removes the need to use an SDK, to use some complicated client library, and really, really important. So you get these, easy interfaces for Fabric and for Ethereum. Wonderful things around tokens and digital assets and key management and wallets as well. And then, tons of different ways to speak to Kaleido and speak to FireFly, right? If you've joined any of the community calls with Nico and Peter and Andrew and that team, typically they're using the FireFly CLI, right? To, sort of very, very easily talk to your local stack. Right? There's also that huge, rich API surface that I mentioned, where you can just use those raw REST APIs to, in the embedded schema to do any doggone thing you want on FireFly. And then there's an SDK, right? The API service, this is ironic, the API service is so powerful and so expansive that there's actually a TypeScript SDK that kind of simplifies, the usage of all this functionality. And inside of Kaleido, inside of FireFly, we'll actually be able to see live updates, of this Node, of this TypeScript SDK, right, as we're using the React front end that's built in. So just to provide a little more context, thought this was a useful slide as well. I'm going to show one more, and then I would have to imagine all of those nodes are up and running. But just to give you an idea of all the things you would need to account for and all the things that you yourself would need to customize and integrate or use a SI to, create these bespoke builds. Look at all of this, right, inside of this ellipsis right here, right? Things around messaging, things around data management and documentation management and storage integrations, right? Things about, leveraging your existing message buses and, how do I take PKI material, encrypt data and reliably move that to, someone else inside of the system. FireFly gives you all of this stuff, right? And if I sound excited, it's because I am, right? It's this really, really expansive, really powerful stack. And the idea here is that you can focus all your attention, right, on those three core tenets that I mentioned earlier, right? Easy integration with your existing stack, right? Smart contract logic, which is incredibly important, but then like the business process flows and the actual application UX, UI that goes on top of it. All the plumbing is there for you, right? And so you can really, really accelerate your journey and get to the point that you care about where you can see ROI. You're not going to see ROI on, creating low-level blockchain infrastructure and, dealing with P2P protocols and crypto primitives, right? You're going to see ROI on, automating your business logic, right? On creating these decentralized networks, right? And creating, wonderful, consumable, composable applications on top of it. So that's really the thesis, the value prop here, of Kaleido and of FireFly is, it's not blockchain, it's all things blockchain. It's your Web3 brain. So hop back into Kaleido and looks like we should be good to go here with all these nodes. So give this a quick refresh and we should see the ability to initialize all three of these FireFly nodes. Cool. Okay. So I think that took probably about 85 to 90 seconds. I know I rambled on a little bit there with the slides, but not a real heavy lift. Just takes a little bit of patience when you create your existing FireFly stacks. Okay, so what we're going to do is we're going to basically initialize these FireFly nodes, and we're going to give them a one-to-one binding with the default Ethereum address that's on their corresponding blockchain node. So the first thing that happens is we'll actually deploy a FireFly smart contract, which is really just going to pin proofs, right? It's going to do a batch pin operation for stuff that happens in the system, right? Public messages, private messages, actual blockchain transactions, anything that sort of leverages the direct FireFly APIs will get referenced on the blockchain. Nothing in plain text, right? Really just a hash, a pin of some identifiers to that data. Okay, so node number 1 is good right here, FFN1. Let's just do the same thing for these other 2 nodes. And again, I don't see the chat, but if there are any questions, feel free to just throw those into the Q&A or raise your hand if you're brave. Sorry, the Zoom bar is always a tricky thing to find on when you're presenting here, so bear with me if I have to hopscotch screens a little bit. Okay, so node number 2 is good, and last one, initialize. I think I saw someone raise their hand. I will do my best to unmute you so you can ask out loud, but maybe easier just to throw it in the chat in the meantime. And if we do have some Kaleido employees or FireFly maintainers on the call, I would I can multitask with the best of them, but if there's some low-hanging fruit on a question, feel free to help me out here before I can get to them. Okay, so this last guy is cooking up, and then we'll be able to very quickly get into the exciting stuff here. Okay, so he's good to go. All right, so now what we're going to do is we're going to actually hop into these nodes, and we're going to see how expansive that API surface and that functionality is that I was just, pontificating about there. So you have 2 different worlds you can go into. You have this web UI right here, which we call the FireFly Explorer, which will show you every single thing under the sun that you could ever want. It is the greatest dashboard. The engineers that built this spent so much time. The design is beautiful, and we'll look at this shortly. But where we're going to start is we're going to actually start with this sandbox right here, which is an incredibly valuable piece that exists both in FireFly open source and both on Kaleido. And what it gives you is, again, all open source. So go grab this code. You have, dynamic React code here on the front end, mimicking, real application, uses that TypeScript SDK that I mentioned on the back end with live application code that you'll see here as we start using these dialogues and using these modals right here, as well as a built-in WebSocket hook for events. So just like incredibly valuable, and you can use this as a template, as scaffolding for real code that you guys ultimately want to write against Kaleido, against FireFly. So 3 columns right here, 3 worlds that we can go through, 3 doors. First is around messaging. Second is around digital assets and tokens. And then the third is around some custom smart contract logic, right? Not using that FireFly smart contract, which really is just 3 lines of solidity, right? Just pinning timestamps and hashes about the order that things happened in. But if we want to bring some more complex code, if this then that statements, then we can use the basic FireFly interfaces and bring our own smart contracts, bring our own custom solidity or our own custom chain code. So we're going to start with the contracts right here. The other great thing about the sandbox, both in OS and both on Kaleido, is that it's heavily documented as well, right? And so it will truly hold your hand as you're going through it, show you how to do things like local compilation of a Solidity file, right? How to generate, an ABI, for example, and even how to actually deploy that smart contract onto Kaleido. So what I'll do, rather than using the CLI right here, is I'll use our built-in REST API gateway that we have for Ethereum, right? And so we've shown this many times in the past, but just as a quick reminder of what this does and how this integrates with FireFly, just bring some Solidity or bring some chain code into Kaleido, into the system, right? If that smart contract compiles, what you get is you get a REST API for any of the methods inside of there, right? And so now you're, relieved of the responsibility of using an SDK, using, the Node.js SDK for Fabric or Web3 JavaScript or Ethers or something, for Ethereum. And you just get, simple interfaces to fire in asynchronous post calls into the system. So what we'll do is I'll just upload some source code into Kaleido into the contract management feature. So I'm going to hop up back to my network level right here. I'm going to click apps. we see that we already have a template, an application or a gateway API for that FireFly smart contract. So let's just go add a new one. All right, we're in the Ethereum world. If folks have met with me before or watched one of these demos, I always use simple storage, but it's a good one because it is so simple. So we don't focus on very esoteric or complicated Solidity things. We just have an integer and a setter and a getter. So I'm going to upload some source from my local machine here. So here's the application wrapper right here, the namespace, and now we just need to populate it with some code. So I'll just grab a local .sol file off my machine, open that, and upload this. And so I'm going to select the contract, simple storage, and click finish, and this will compile and spit us out the bytecode in the binary interface. And what I need to do while I'm doing this is I actually need to deploy this smart contract onto the blockchain, right? Because what FireFly wants is, FireFly is going to say, hey, tell me about the ABI for this smart contract, right? So I can actually, give you some APIs, some RESTful interfaces, and then it's going to say, well, tell me about the interface that you use, and then tell me the address of where this thing is on chain so I can actually proxy those calls so I can let you talk directly to this smart contract. So we need to do these two things right here, right? We need to define the ABI for this simple storage code right here. And then we need to actually tell FireFly, tell Kaleido about that hexadecimal smart contract address. Okay, so as soon as this guy compiles right here, what we'll do is we'll promote it, right? We'll push this API definition into that FireFly environment that I created, and then we'll use the REST API to just fire in a quick post call to instantiate this thing on chain. Okay, so I'm going to say promote. Keeping my eye on the time. I do want to leave a few minutes for questions if there are any. Okay, so I'm going to name the API's SS. I'm going to push it up to ffdev. And super quickly, I'm just going to say view API, and I'm going to instantiate this with the Ethereum account on node number 1 right here. So we'll just say view API. It's empty argument to the constructor right here. Again, here's the default account we're signing with. And I'll just, this doesn't matter, but this is a super cool query parameter that's available in ETH Connect. It's just this, arbitrary naming parameter. So I'll call this SS123. But what we'll see is FireFly doesn't care about this. What it wants is actually the raw Ethereum address, the smart contract address. Okay, so this guy is live on the blockchain. So we can go back, click right here, and we see that we now have an instance. So what FireFly wants is actually this guy right here, wants the smart contract address. So I'll copy that. First, we're going to go ahead and define the ABI, right? We're going to teach FireFly about this smart contract, about this source code, about those methods. So we'll just give it a name of SS again, same conventions, and a version of 1.0 right there. Okay, so run that. I should note, it's pretty obvious if you're watching, but everything's asynchronous in FireFly, but it's built on events, right? There's like so many events that flow through the system. So, you'll see your FireFly events, you'll see your blockchain specific events, you'll see your token events. And so it's really just about, ingesting things you care about that are being propagated through the system. Okay, so all successful there, taught it about the ABI right here. And now we just need to tell it the smart contract, right? And so again, I'll just say SS right here for cheat code, and we'll give it that address right there. So click run, and now something really cool is going to happen, right? You see this no APIs registered with FireFly, right? As soon as it successfully ingests and consumes that smart contract address and associates it with this binary interface, now we get an open API. We get a Swagger interface and an endpoint, for that matter, that we can talk to programmatically. That we can use the easy button to speak to this smart contract, right? And so we can literally just click this button right here, and I have interactive Swagger for that not complicated smart contract that we just looked at, right? And so very, very simply, right, we can go ahead and invoke this smart contract, right, directly from the Swagger, but also programmatically, right, from this kind of request URL right here, right? And so again, asynchronous response right here, right? And so we see actually that the status is pending. And if we sneak back to, FireFly quickly enough, right, we sort of could see the transition right here of, something's been submitted, but it hasn't fully succeeded yet, right? And so you see the asynchronous model in form there. Okay, so last thing we want to do in the smart contract world is we just want to create a custom listener, right? And so, as we look at Solidity, most folks will be familiar with this. very, very straightforward interface called events inside of there. And you can define these events, give them any arbitrary name that you want, and determine what type of information you want coming out of the blockchain, right? I want to see all these inputs. I want to see who signed this transaction, et cetera. And then you can just code invocable functions to emit that event. And so what we'll do on FireFly is we'll say, hey, I care about this signature called changed right here. Okay, so hop back into the interface right here. Super simple, right? We're going to say, hey, this is the API we're using. This is the event that's available, changed right here. We're going to send it onto, topic 1, for example. And then we could even give a custom name for this listener, right? I'll just call it changed as well right here. Okay. And so we can go ahead and run this. We can go ahead and kick this one off right here. Again, asynchronous. This actually isn't a blockchain transaction. This is just internal inside of FireFly, right? And this is just saying, hey, I know about this API. I know about this smart contract. I know about this signature. Just tell me, like, what topic you want to associate it with. And every time you call that set method, I'll go ahead and give you this data, right? And so if we go back to our Swagger, again, sorry, I had to move the zoom bar. We just invoke this thing and change the value to 98, for example, and click execute right here. We'll see some additional information coming out of FireFly right here. So we see the contract invoke, right? But as soon as that makes it, right, as soon as that transaction actually gets executed, now we get an event. Specifically, we get this unique event ID, right? And now let's go into world number 2. Let's go into the FireFly Explorer. Won't have enough time on this call to show you all the bells and whistles of the FireFly Explorer. It is, again, maybe I'm a little biased right here, but it is just an absolutely beautiful, interface that tells you so much information about what's happening, right? And so we can go to the blockchain tab right here. We can go to the events, and boom, we see a changed event, right? We see it associated, right, with that exact same ID that we just looked at inside of FireFly. We can click on this, and now we can start seeing interesting things, right? We can see the identity that signed the transaction. We can see the inputs that were passed to it, right? And so this is the stuff that, your application's ingesting, that you're automating your reactions to right here. We can also see the transaction, right? So if we go into transactions right here, we see that there is a contract invoke, right? So we can click on that guy, we can follow him through right here, and we can see real rich information associated with this transaction, right? Actually sort of like how FireFly spoke to it through that FireFly interface. So a lot of the same information, but seeing the identity that signed it, seeing the smart contract address, seeing the inputs right there. So as you use the sandbox and as you use Kaleido and FireFly, really encourage you to spend a good deal of time kind of familiarizing yourself with these different classes and these different buckets. There's just so much awesome, so much rich data inside of here that gives you information about what's happening on the blockchain, what's happening off the blockchain, and so on and so forth. Okay, so that's smart contracts right there. What should we do next? Let's go to messages next after smart contracts. And again, I see there's some stuff coming into the chat. I'm going to click on it real quickly and see if I'm getting any help. Yeah, okay, thanks, Trevor. Okay, so now let's talk about messages. This stuff's really awesome too. So 2 different types of messages, right? Something that we send to everyone out in the world, right? We call that a broadcast message, where the actual, attachment or JSON payload or string will get stored in IPFS, right? We saw that when we created our FireFly stack, we were asked to create not only a blockchain node, but also kind of like this public storage utility, IPFS. And so that's where it really comes into play for, public data, right? Stuff that everyone's supposed to see, inside of the ecosystem here. So we'll just say, hello world right here. We can optionally add a tag and associate with a topic. And you see these options right here to, really demarcate and really delineate between different classes and different types of messages that are flowing through your system. So you can associate, different message classes with different business processes or different recipients or, whatever makes sense, right? Specifically in your industry, in your consortium, in your vertical. So this is very straightforward right here, right? We're just saying hello world. And what we'll do is we'll go prove that, all of the nodes, all of the Firefly explorers have the ability to ingest and see this transaction right here, right? And so we see again, those events coming through. So let me close this Swagger UI and we'll open up a couple other explorers right here. So we have one open for FF1. So let's open one for FF2. And let's open one as well for FF3. Okay. And now we're going to go into the messages tab. Okay. So this is the guy that sent the message. So kind of goes without saying that he's going to be able to see that data, right? So if we go to, this is organization number 1 right here. So if we go to the messages tab right here, we'll see that, he broadcast a message, no topic, no default topic rather, but no tag, right? So we can click on this right here and we'll be able to see, what was passed in. Hello world, right? We have the hash right there, which is just a SHA-256 hash of the payload. So if you guys actually want to recreate, this is very straightforward as well, but if you wanted to recreate that hash, you can just go to like a online SHA-256 emulator, right? So this is 9DDEF. And again, this is a string, right? Hello world. So there it is right there, 9DDEF. But again, the SHA-256 works, deterministically for any arbitrary payload. So really more of just a utility function. So we proved that node number 1 can see this. Let's check on our other 2 nodes, right? So if we go to node number 2 right here, yes, he sees it as well. Hello world. And then lastly, if we go to node number 3 or Firefly org number 3, go to off-chain, go to messages, he sees it as well, right? And that goes without saying. That's a broadcast transaction. Everyone should be able to see it, right? We could even like make an API call if we wanted to IPFS and pull down that data, right? If it was something more interesting or like a rich attachment or a PDF, right? There's it's highly likely that you would want that data. Okay, now let's take a peek at kind of the different type of messaging, private messaging. Okay, so rather than sending something to everyone, let's send something from organization 1 to organization 3 and prove that this guy right here, org 2, can't see it. So we want to obfuscate the data from H9Q right here, this org, and we want to make sure that this guy right here, oops, sorry about that, right here, LHF, this org is going to be able to see it. Okay, so let me just say that again for my own memory. LHF. Okay, that's the guy I want to send it to. So we'll go back to the sandbox right here and we'll say, hey, let's send a private message this time. Okay, and so again, we're going to just send it as a string. So private info right here. And now we need to define the recipient. So LHF, that's still in my memory right there. So that's the guy that's going to get this right here. Again, optionally associate a tag with this or a topic. It'll use the default topic if you don't. And just fire this off, right? And what we'll see here is we'll see something similar to this type of architecture, right? When we talk about the document store, right? Imagine there's a third organization hanging out in the middle right here, right? Client C, right? All we're proving is that client C is not going to have any line of sight into this payload, into this document. It's going completely bilaterally or trilaterally, if that was even a word, right? It's just dependent on how many organizations you have and who needs line of sight, who needs access to that document or that payload. Okay, so let's go ahead and kick that off right there. And then, mechanically, what we're going to do is, pretty much the same thing we just did. We're going to go into the messages. We're going to prove that, org 1, the sender, org 3, the recipient, have line of sight into this private payload, but that org number 2 has no line of sight right into this. And all that they know is that, some blockchain transaction where some data got pinned occurred inside of the system. Right. So if we go to org number 1, again, this guy's the sender, right? And so we do a refresh, we'll see that he sent, a piece of private information, right? The first transaction is defining the group, right? Saying, hey, I'm going to send this between, myself right here and this other organization, right? And so here's the guy that we sent it to. Here's the guy that we sent it from, right? It's called a group init or a group definition right here. And then here's the actual payload right here, the actual transfer, where we can see private info right here. And again, we could hop back into that online emulator and recreate that hash really simply if we wanted. Okay, so the sender sees it, right? That's not surprising. But now we're on node number 2, right? This guy that we didn't get invited to the party, right? Doesn't need line of sight into this. And he has no clue, right? He sees nothing in terms of messages. If we go to activity right here and we go to blockchain transactions, he'll see that something got pinned on the blockchain, right? That it was sent to the FireFly smart contract, right? That the author was organization number 1 right here, but that's all he knows, right? He has no clue of anything other than org number 1 invoked some type of private transfer or something that he doesn't have line of sight to. So you have this just wonderful obfuscation of privacy that's available. And then if we go to org number 3, right, he's obviously going to see this transaction as well. So he can see private info just like org number 1, the sender did. Okay, so pretty straightforward there, not rocket science, but incredibly important when we start talking about healthcare and doctor-patient records, or we start talking about supply chain and bills of lading or contract invoices or legal PDFs, right? This is in insurance, in healthcare, in financial services. There is always private data that you're going to get a lot of value about referencing that data on the blockchain, right? Proving that it hasn't been tampered with, that it exists. But there's always a requirement, some with a higher percentage than others, to securely move this data, right, via message bus from one organization to another organization. And you can start doing really cool things too, right, when we talk about private data, right? For example, integrating token economics and forcing people to actually have to pony up some allocation of tokens right before you're willing to send that document to them right there. You can use it for arbitration, right? All sorts of really clever use case specific things that are possible here with private messaging and with all the functionality that's available. Okay, so last thing here inside of the messages column right here, we see this define a data type. And this allows you to authoritatively dictate a schema, right, for types of messages. So you want everyone, that's, sending fire documents, for example, right, or, sending financial message information. You need them to conform with the exact same schema, right, the exact same representation of that data. So what you can do is you can, arbitrarily define your own JSON schema right here, give it a name, give it a version, and this will be shared with the entire network, right? And so they'll be able to say, oh, hey, here's a new data type definition right here, right? I need to make sure that, my payload conforms to this data type. And so we have a really simple one that I'll show you right here. So I just named it schema.json. And what we'll see, it's sort of a key value pair, right, in a JSON payload. And the two things that are required is the key, right, is going to need to be specified its name, and then the value is going to have to be a string. So we'll go with a couple examples, right, where I try to put something other than name right here as the key, and we'll put, integer, for example, as the string. So I'll just copy this whole 10, 12 lines of JSON right here and hop back into the sandbox. So I'll delete the placeholder schema right here, and we'll just go ahead and put this guy in. And I'll just call it DT1 for data type 1 and version 1.0 right here. Okay, so we'll send this, we'll broadcast this to the entire network saying, hey, there's been a new data type created, DT1 needs to conform with this schema right here. And then what we'll do is we'll try to broadcast a message and not really play by the rules, right? So let's go ahead and not conform to this data type that we dictated, right? And so you see here, these are kind of the 3 different worlds or 3 different types of data, I guess, that you can send for public or private. You can send a string, you can send JSON, or you can send form data, right? You can actually attach a, I don't know, JPEG, a PDF, right, what have you, something that doesn't make sense to get represented kind of in JSON. So we're going to say, hey, let me conform with this data type DT1 version 1.0 right here. So first we'll try to, not play by the rules, and we'll just say, instead of name, I'll say Nick and put my last name in here as well, right? And so we're going to say run this right here. And what we should get is 500, right? We do from the server. And so it's saying right here, missing properties name. right? This is another awesome thing about Firefly too, is the logging is so intuitive, right? And so if you do something like this, it's going to spit out, hey, you did this wrong right here, right? You're using data type DT1 version 1.0, right? Go look at that schema, and you can realize, like, literally just go grab the schema and you can say, oh yeah, I missed the name field right here, or the name key, right? And so if we give it the name key right here, and then say, instead of a string, let's just give it an integer right here, we'll see, or we should see, another 500, right? And so now it's saying, hey, I expected a string, but you got me a number. Why don't you, conform to this data type schema that you defined? So finally, I'll play nicely, and we'll just say, name is Nick right here. Okay, and now we've left name as the key, and we've provided a string with quotes right there. And now the server says, thank you, finally, here's a 202, you're off to the races here. So data types are awesome, right? Like, as extensible and flexible as you need them to be to, dictate, how your organizations, right, want to conform with, both public and both private, different subsets of data. Okay. Nearing the top of the hour, and I will show you the final thing, probably the coolest thing that exists inside of Firefly and inside of, well, it's all cool, right? But just like some of the UX and interfaces that are available for the tokens are really, really doggone cool. So the first thing I'm going to do is I'm going to go back to Kaleido and do something similar to when I deployed simple storage. I'm going to go say, hey, Kaleido, let me use some of your templates, and let me get a an ERC20 token smart contract. There will be increased functionality inside of the sandbox to just press a couple buttons and have a token at your fingertips. At the moment right now, you need to, this is not an onerous redirect or anything, right? You just use the built-in utilities that we have in Kaleido to kind of marry with and accompany your sandbox and your Firefly stack. So I'm gonna do it through node number 1 right here, org number 1. He's gonna be the creator and instantiator of this token. And I'm gonna say, hey, Kaleido, let me use your templates, right? I don't wanna go to OpenZeppelin. I don't wanna bring my own, custom code. I just wanna use your templates. So we're gonna use this one right here, Firefly ERC20 with data right there. And now I'm going to do this in real time, and this is important. Don't let your eyes bleed, but this takes a little bit of time right here. There are a lot of things that are happening in the background, right? Similar to when we, instantiated that Firefly stack, right? There's tons of orchestration that's happening. Specifically here, what we're seeing is Kaleido's going and getting that source code for us, right? That rich nested ERC20 code, right? That has all of those dependencies that you're familiar with in OpenZeppelin. It's compiling that code, right? Just like we did with simple storage. So it's using a Lambda function to do that. Then it's promoting that code, right, into our environment, ffdev right here. And finally, it's going to give me a chance to actually instantiate it. So if this takes 60 seconds for you, don't think there's something wrong with the system. Just understand that there are a ton of things happening on the back end in Kaleido, but it's worth waiting 60 seconds, 75 seconds, because at the end of the day, you get wonderful REST APIs to talk to this smart contract, and you can start leveraging the Firefly sandbox as well to talk to this smart contract. So yeah, conscious this is a little slow. Probably this will require the most patience, I guess, inside of the system. And as I mentioned, shortly inside of the sandbox, inside of Firefly at large, you'll see richer utilities and sort of fast forward buttons to create your own 1155s, ERC20s, 721s, etc. So I was true to my word. It's definitely taking 60 seconds right here, but wanted to sort of go through the pain, I guess, along with the audience right here, just so you don't think there's something specifically happening on your machine or on your Kaleido environment or on your specific instance. Just byproduct of how fast the Lambda function's working, right? How long it takes that code to compile, etc. So hopefully in the next few seconds, this will spit us out the interface so that we can actually instantiate this smart contract and get the address back. And similar to simple storage, what we're trying to do ultimately is we want to tell FireFly about this token address, right? So it can then use its connectors, its plugins to help us very easily speak to the smart contract. So yeah, this is a little longer than I expected, right? Doing my best to sort of fill the noise here and fill the gap. I may try a hard refresh real quickly if this doesn't come out in the next couple seconds. I also have this orchestrated in another environment. So if this is not going to play friendly with us for whatever reason right here, I'll just switch to a different environment where we already have the tokens instantiated. So let's go back and let's see if this actually worked first. So let's go to the apps, smart contracts. So no, okay, so let's just switch environments right here for sake of time. So right here we have ff-test2, very same orchestration that we just looked at, right? Even the same naming conventions. And so let's just hop into the sandbox for node number 1 in this environment. So I'll close these explorers and we'll go into this guy right here. So I'm going to go ahead and open the web UI right here. And what I did to give you guys a little bit of context right here is I've already defined a token pool, right? I defined one that was called, oh, you know what we can do? Actually, I got a better idea. We'll create another one since I already have the API defined. So let's go ahead and go to my apps right here. Go to smart contracts. And so this is what we were looking for right here for this guy to ultimately come out. So let's just go ahead and deploy another one right here. So go ahead and say view API, and we'll just fire this guy off right here. All it needs is a name and a symbol. So we'll call this, I don't know, TT for Tech Tuesday, right? And we'll give it a symbol of TT right here. Okay, we could give it, that human-friendly naming convention, but again, all we're really after is the address right here. So we'll instantiate this guy and we will then start talking to it right here. Okay, so contract address right here, B791. Okay, so that's what we're after. So if we go back on the breadcrumbs right here, this is the guy we want right here, B791. So go ahead and copy that. And now we'll teach FireFly about this dude right here. So TT, it's a fungible token, it's an ERC20. And here's the address right here, okay? And so we see I already did this with a token called Acme, and I have 90 tokens right there. But what we'll see is we'll see another token called TT where my balance is 0 for this guy, okay? So that creates another token pool for us, one called TT, again, asynchronous execution right here. So I need to wait for this to fully make it onto the blockchain and execute right there. So that's good. And now we can go ahead and sort of, start trying to do stuff with, this specific smart contract right here, this B791 right here. Okay, so first thing we can do is we can just mint a new token, right? And so it's saying, hey, use the TT pool or use the Acme pool right here. And so we can mint a new token. Maybe I'll give myself 100, for example, right? Go ahead and run that. And we should see an update up here for, 100 tokens generated for this TT pool right here. Okay, so we see that. And then the other things are really straightforward, right? The tokens are so fun because you get this unbelievable view inside of the FireFly Explorer. So what we can do, for example, is, let's send some tokens to, another one of the nodes inside of our network, right? And a couple of ways to figure out their identities. So if we go back to FireFly right here, go to FFN1 and open the web UI, you have an organizational map, right? You have this network map right here. But if you go to the network tab right here and click on the organizations, now you'll see, who else is inside of the system, right? And so we can see org1, org2, org3. If we click on one of those nodes, we'll see a corresponding Ethereum address, right? A7E4 right here. And so let's send some tokens to that guy, A7E4. That's either node 1 or node 2 or node 3 right here. So if we go to node 2, yeah, so it's node 3, right? This is who we're going to send the tokens to, A7E4 right here. Okay, so copy that address right there, go to the transfer option right here, and let's just say this guy's the recipient, right? And we'll send him 10. Okay, so go ahead and click run. and that will, decrement us 10 right here as soon as that executes, and that will give 10 to this other guy. And inside of the Explorer, what we'll notice is seeing these balances and being able to audit the transfers and being able to play catch up if you're, a new application coming online. All of that is so transparent and so easy to view, right? As are failed transactions, right? And so I only have 90 tokens, right? What if I try to transfer this guy 100 tokens, right? What's going to happen? Is Firefly going to be as friendly to me with the error message, right? And the truth is, yes, it is. It's going to tell me, a little bit of information over here in the raw event, right? But if I go back to the Explorer, right, and I start looking at, specific, events that have happened or specific transactions that have happened, right, we can dive a lot more deeply into this, right? So we can say token transfer failed, right? Why did it fail? Tell me some more information about it. And so what you do is you just go downstream to the transaction ID right here, and you can say, okay, here's this token transfer that failed. What's going on, right? And you can open this up, and now you're going to see, the rich linting, the rich logging that's available, saying, hey, this, you can't transfer, more balance than you actually have inside of the system, right? And so, this logging, this eventing, this recording of, all of this rich data, you start to get the idea of how holistic Firefly can be for your consortium and for your business. And then you couple that with, running it on Kaleido with, all of our enterprise grade blockchain infrastructure and all of our easy integrations onto AWS or Azure. You kind of get the idea of like how powerful this whole composable stack really is right here. Mentioned, what I think is, the coolest piece inside of the Explorer is just all things tokens right here, right? And so, you can see the different pools, right? And, pretty much everything will let you dive deeper inside of Firefly, right? And so, you can, dive deeper into specific account balances right here, into specific pools and see, okay, well, tell me the stuff that's been going on with this pool, and, who has addresses here inside of this pool, and, what are the most recent, activities, whether it's a mint or a transfer right here. Right, and you can scope this, right, as granularly or as macro as you need it to be, right? Dynamically updating, React front end, all these dashboards right here. So yeah, really love the tokens. Love some of the icons that are available. Maybe we should do a burn because that has a really cool icon as well. So let's go in here and let's just burn a token. Okay, so we'll just burn one. We don't want to light the world on fire right here. And what we'll get is we'll be able to see, a new transaction, a new record, right, inside of the Explorer as soon as that guy executes right there, showing that, something beyond a mint or a transfer has happened, right? We now see, the flames coming out of the earth because we've burnt a token right here. So yeah, that's a pretty whirlwind tour of, of Firefly, of Kaleido. The Kaleido platform is, really expansive, has a bunch of horizontal depth and functionality as well. So, as you're, putting your sysadmin hats on and, you want to do stuff around key management, or you want to do stuff around, resource management, you can leverage the raw Kaleido APIs or the admin console as well to, see all of this information. So that's kind of how the two pieces fit together right there. They're very complementary. And, I truly hope that, this was a, decent representation of, both Kaleido and Firefly. But what I really wanted to get across was, that it's unintimidating, right? Regardless of how expansive and how powerful it is, but B, that it's sitting there like a REST API away from, you developing, the next great application for your business and your consortium. So that will wrap it up for today. Thanks, Trevor, and other folks that have been helping out in the Q&A. If you do need to get in touch with either myself or the Kaleido team, you can reach me directly. You can just send me an email right here to my email. It's my name at kaleido.io, just like every other employee at Kaleido. If you are, creating an account and have any questions about the product, you can reach us with this help and support button and just say contact us. Or you can email support@kaleido.io if you have, commercial or technical questions.
And Nick.
Yeah, sure.
We did have one open question in the Q&A I was hoping you could grab. I don't know if you can see it there, but the question is, can we manage access control? Which member can call and invoke which smart contract functions through FireFly Sandbox?
Yeah, so this would, so what you want to do there is you want to use what we call the blockchain application firewall. You absolutely can do that. The sandbox is an example of the art of the possible on Kaleido and FireFly, right? It is just, built-in baked React and TypeScript backend code for you to play around with. When you put your true like enterprise, solutions architect, sysadmin hat on, and you want to do that end user application RBAC, right? Then what you would do actually is you would integrate with this service that we have on Kaleido. It's called the blockchain application firewall. And what it lets you do is it lets you define as sophisticated as you want rule sets that can sit in front of your node, right? Specifically what, the person asked, Kevin, of like, hey, who can talk to this smart contract? What key are they allowed to sign with? What method can they call right there, right? You can have read-only rule sets. You can have admin rule sets. You can have, very, very bespoke, granular, different tranches of permission, using Bath and using this, JWT OAuth redirect. You can also scope these permissions directly just with application credentials as well, which kind of is a nice crawl, walk, run sort of model right there if you're, experimenting with this. Basically just saying like, hey, when I create app credentials on Kaleido, I have a username password pair. And, for example, here's a username and I'm going to say, yeah, we're going to create a rule set for Nick. And we're going to say, hey, he's going to authenticate with this, this username right here, along with his secret. And let's make sure that that account can, only talk to smart contract XYZ and invoke this method right here. So yeah, it's a super question and great that that's where your head is at, because end user RBAC is incredibly important, as is just the network RBAC that's in Kaleido.